Good morning students. In this class we are discussing about the power amplifiers. Okay. So in previous discussion we already learned about multi-stage amplifiers and feedback amplifiers. So what is the meaning of multi-stage amplifier? The output of the first stage is connected to the input of the second stage. Okay, this is called multi-stage. We can use number of stages. The purpose for multi-stage is to increase the input signal strength. To increase the input signal strength. Coming to the feedback amplifier, here the concept is the part of the output is feedback to the input. So those amplifiers are called feedback amplifiers. The advantage or application for these amplifiers is it increases the voltage gain and reduce distortion. Okay. Now, what is power amplifiers? So why we need power amplifiers? We have to discuss here. Consider a public addressing system, general block diagram. So this is a multi-stage amplifier. Okay. Here the last stage which is connected to the load, that stage is called power amplifier. Okay. The last stage which is connected to the load. Here the load is the loudspeaker. So this is the public addressing system block diagram. The last stage which is connected to the load is called power amplifiers. The input stage and the intermediate stages are called voltage amplifiers. Okay. Here the intermediate stages, these are the intermediate stages. The intermediate stages are provide sufficient voltage gain. So these stages are called voltage amplifiers. It provides, all these stages provide sufficient voltage gain. So that's why these stages are called voltage amplifiers. And the final stage, that is the power amplifier. The main feature for this power amplifier, it has to deliver maximum power to the maximum AC power to the load. So that is the main feature for the power amplifier. For any multi-stage amplifiers, the last stage must be power amplifier. Okay. Now we are considering what are the differences between voltage amplifiers and power amplifiers. So voltage amplifiers and power amplifiers. So the first point is voltage amplifiers are small signal amplifiers. The another name for the voltage amplifiers are small signal. Power amplifiers are the large signal amplifiers. And next, the basic function is to provide high voltage to the load. So here the basic function of the voltage is high voltage to the load. So here voltage gain is important. Coming to the voltage amplifier, the main important feature for voltage amplifier, it has to provide high voltage to the load. Similarly here the basic function is to provide high power to the load. So here large voltage and current signal handling capability is important. This point is very important. Large voltage and current signal handling capability is important. Okay, so here high voltage to the basic function is to provide high voltage to the load. Here reverse, high power to the load. So voltage amplifiers are analyzed by using H parameters. So because of high power handling capability, H parameter analysis is not applicable here. H parameter analysis is not applicable. Okay, next, the transistor used has low power rating. So here in voltage amplifiers, the transistors are using low power rating. Transistors used as low power rating, so small in size. Due to the large power handling capability, the main function of power amplifier has to deliver maximum power to the load, AC power to the load. So due to the large power handling, the transistor used is a power transistor here. Power transistor, large in size. Generally it is large in size, having large power handling capability. So because of small size and low power rating, heat sinks are not required. So here because of large power rating and large in size, heat sinks must be present. Heat sink requirement is necessary. Next, here distortion analysis is not important. Distortion analysis is not important. Here in power amplifiers, distortion analysis is very important. Okay, next. And one more point here is voltage amplifiers are generally classified. Voltage amplifiers are generally classified depending upon the coupling elements. So power amplifiers are classified depending upon the output characteristics of the power transistor by considering the Q point on DC load line. Okay. So generally for coupling, for voltage amplifiers, R and C elements are used. For power amplifiers, they are coupled by using transformer coupling. So transformer coupling is generally preferable for power amplifiers. Why? Because the important feature for the transformer coupling is impedance matching. So generally the output stage is matched with the load. Here the loudspeaker is a low impedance device. So we have to match the impedance. So these are the some differences between voltage amplifiers and power amplifiers. Thank you.